Okay, exponential growth. Here's the thing you want to remember to get this concept down. Exponential growth is repeated multiplication. Exponential growth is multiplication over and over and over again. And you're keeping track of that multiplication. So, for example, we did some examples with lines about car depreciation last semester. You buy a car. You drive the car off the lot. What has already happened to the value of that car? It's gone down. Now, we looked at linear models, lines, that can actually model that, but sometimes it doesn't go down in a linear fashion. It depends on the car, it depends on the state of the economy. I don't know what it depends on. I don't know a whole lot about it. But we're going to say that, what's an expensive car that goes down in value very quickly? Does anyone know? Mercedes, what else? Maserati?
Or a GM,
Really?
considering you're like going out of business.
That could affect it. All right, what's the nicest car General Motors makes? Anybody know? What do they make? Jeep Wranglers, that kind of stuff? Okay, I'm going to go with the Jeep. Okay, you...
I think GMs make... She doesn't really make it.
Okay, you buy a Jeep. Okay? It's a nice Jeep. All right? The Jeep loses 5% of its value each year. Okay? Let me see if I have another marker real quick. Can you check my desk? Actually, Dean, can you toss me that blue one on the desk? Yeah. Immortalized forever. Yep, okay. So you buy a Jeep. It goes down 5% a year. Now, with this Jeep losing 5% of its value every year, that's a little bit hard to actually model. So what you sometimes want to do is switch this around in your head. How much value is it retaining each year?
-5.
Sort of. Not as helpful to the model. Versa, would you say?
95.
Okay. Therefore, it's much better. It retains 95% of its value. How do you figure out 95% of something? This is a middle school problem. You probably haven't thought about it in a while. How do you quickly figure out with a calculator?
5% of it. We'll figure out 10% and then divide that in half and then multiply it by 95.
That would be useful for figuring out a tip. Well, that's an extra step, though. There's an extra step in there. You're right. That would work. What's the quickest way to do it in a calculator, James?
Isn't it like that the thing over 95?
Not over 95. You're thinking about setting up the proportions?
95 over 100 equals what over... Or no, equals...
You're closest.
X over
You're closest.
price.
Okay, you guys learned a very good way to do this in middle school. I'm apparently going to teach you a new, faster way.
No.
What decimal is 95 over 100?
No. I know your new way. It sucks.
0.95.
0.95. Okay, here's the other. I think you might like this one, actually.
No,
Retains 95% of its value. Okay. To determine, okay, the new value, to determine 95% of something, multiply by 0.95. That's all you do. You multiply by 0.95.
I don't like it.
You're going to want to do this, trust me. Okay, I'm going to move over here now. So all you're going to do is multiply by 0.95. You don't want to set up the proportion for each step of this problem. How much does a new Jeep cost? Anybody know? Ballpark? What can you get a Jeep for? $20,000. $20,000. Okay. You buy the Jeep for $20,000. When you drive it off the lot, its new value is $20,000 times 0.95. Who's got a calculator handy?
He does.
Amy does. Maya does, right?
Where am I bad?
Okay. What's 20,000 times 0.95?
19,000.
19,000 exactly? Okay.
It only goes down $1,000.
Yeah. Well, still, that's for owning it 10 minutes.
Per year.
So that's kind of...
But that's also per year.
That's also per year, right.
Percent per year. So not necessarily as soon as you drive it off the lot. If you don't have it for a full year, then it would be a less percentage.
Yeah, but if you turn right around and try and sell it after you've driven off the lot, you're already going to be paying less. This isn't a perfect model, but we're not going to get every detail of it. But 1 year later, it's lost another 5% of its value. So what do you think we do now to determine its new value?
0.90 times.
That's not exactly how it works. That's a good guess. It's
See, this is why we
19,000
recorded.
times 0.5.
yeah. What we do is
0.95.
it's losing 5% each year. Okay. When we get to the growth example, you'll see why this isn't as bad. What we do is we now multiply 19,000 times 0.95, and what do we get? What?
18,050.
So would that not be the same as doing
No, it's not the same thing as doing 0.9 times 20,000.
what?
What you were suggesting is that it loses 5%
Yeah.
each time. So to find 90%,
Okay, I got it.
it's not the same. Now, year after that,
It's only 50 less. It's only 50 number difference.
it is only a 50 number difference in this case. You're right. Year after that, you would multiply 18,050 times 0.95. And what would you get then?
17,147 and 50 cents.
17,147
And 50 cents.
and 50 cents. Okay, so the numbers start to get a little uglier.
That makes sense.
Okay, so what we're doing is we're multiplying.
Wait, Mr. Bell, I have a question.
Yes.
If it's only 1 year later, technically you've only had the car for a year, and so it would still be 90,000. Because you said 5% a year. So you have to have it for a year before it goes down 5%.
It
So
depends
that's
on whether you
2
count.
years later.
It depends. 1 year later, year after that. It depends on what you're counting. That's a good point, though. You're raising an excellent point. Do we start counting with 0 or 1?
I just want to get my car for the right price.
Yeah, you're right. You do. I am counting the moment you drive it off the lot as part of year 1, not year 0. Does that make sense for the question you're asking?
Yeah, but it's still retarded.
All right, I'll keep that in mind. It's way a lot. I'll use an example that's more true to life for the growth one.
Okay, good.
All right. The point is, what we're doing is we're multiplying over and over again by 0.95.
So it's good.
So it's 0.95 is less than 1. So the numbers are going down.
You have it under exponential growth.
I do have it under exponential growth. You're absolutely right. This will actually be a decay. You're right. And this will be a decay example.
So then it's not repeated multiplication.
It's not which?
Is it still repeated multiplication?
Yes, it's still repeated multiplication. It's repeated multiplication by a decimal less than 1. You could start to think of it as repeated division, but please think of it as repeated multiplication for my sake. Right, for the sake of my sanity right now. So excellent questions. You guys are asking very good questions. I'm still a little infected. Pardon?
I don't care about your sanity.
All right, so, okay, so what we're doing is the value of the Jeep over time. If you guys didn't like f or x or g of x, check this out. Now I'm using a whole word instead of f or g, and I'm using time instead of x. The value of the Jeep over time is the starting value of the Jeep. Okay, the starting value of the Jeep multiplied times 0.95 over and over again. How much over and over again? It depends on how many years you want to talk about.